Okay, so we just talked about a parallel circuit, right? Now we're going to combine the two together, series and parallel at the same time. So if you look at this circuit that you see on your page, you'll see that it has a series, right, one path, and then I get to a junction here where I have two choices, and then it comes back together and goes the rest of the way series. So the overall type of circuit here, the big picture, is a series. It has one part of a parallel in it. Okay, so there's a combination of series and parallel together. Does everybody understand that? Okay. Whenever you see a circuit like this, you're going to take and reduce whatever you can. So in this case, I want an overall series circuit. Okay, that's the big picture. That's what we just talked about. So I'm going to reduce the parallel portion into one resistor. Okay, so I'm going to combine them together to make them into one. Okay, so how do I combine parallel resistors? As fractions, right? 1 over R plus 1 over R. That's what I'm going to do. That's the first step. That's what I'm going to do. I'm going to simplify wherever I can. So I'm going to make a new resistor, and I'm going to label it R23. R23 is the inverse sum of 1 over 4 plus 1 over 12. We're following rule number 2 for parallel circuits. 1 over 4 plus 1 over 12 is what? You got 3 for the inverse? Right. Okay. So now I'm going to redraw. I am a visual person. If I don't see stuff, I have a tendency of making mistakes. So I'm going to redraw my circuit so that way I have the overall series. All right, this is R1, this is R23, and this is R4. Okay. This is my simplified circuit. What type of circuit do I have now? Series. Do I know how to find the total resistance in a series circuit? How do I find the total resistance in a series circuit? Add them all together. So this is 5. This is 3. And this is 8. 5 plus 3 is 8. 8 plus 8 is 16. So that's my total resistance. Now I want to calculate I total. Do I need to look at my picture for I total? Not really. All I need are two things, V and I. Do I have V total? Yeah, right here next to the battery. What is it? 24. Do I have R total? I'm using Ohm's law. V total over R total. What'd you say it was, Corey? 1.5? Thank you. Okay, now let's look at this as just a series circuit. We're going to ignore the original picture right now. What do I know to be the same in a series circuit? What is the same no matter where I am? I, current. Okay, so I'm going to fill in information that I know is going to be the same as I total. Which currents are the same as I total? R1 and R4 right? So I can put 1.5 here and 1.5 here because those are in series, so therefore the total is the same everywhere. Now, what can I do? If this is a series circuit, what else would you be doing? I know this technically I23 is what? 1.5, right?
Yes.
Okay. I1 is 1.5 and I4 is 1.5. Right? Find V. That's the next step. How do I find V1? Yeah. I times R. I1, 1.5. R1, 5. What do you get? Okay, find V23. What do you get? 4.5? Okay, then you find V4. What do you get? Now you can always check to make sure you're not making errors or not using the wrong numbers, because let's say you used the wrong number and you got 36. Can it be possible for you to have a voltage that's 36? No, it can't be greater than the total. The total is 24, okay? So the sum of these three right here in our series circuit has to be 24. So check to see if you got that. 7.5 plus 4.5 plus 12. It should be 24. Everybody understand that? Okay. Now, how are resistors 2 and 3 connected to each other? Series or parallel? Parallel. What do you know is the same everywhere in a parallel circuit? The voltage. So R2 is going to be how many volts? 4.5. Because R23, or V23, sorry, is 4.5. So whatever you get for the combined voltage is now what you put for both V2 and V3. Because they're connected in parallel, they have to be the same. What is not the same in parallel? Your I. Okay, your I's have to add up to 1.5. So now I need to find I of 2 and I of 3. What's V2? What's R2? 4. Once you get I2, all you have to do is say, oh, well, I know it has to add up to 1.5, so I can do 1.5 subtract I2. That's the easy way to do it. Okay? So what'd you get for I2? 1.1. So that means I3 has to be what? 0.4. That should also make sense if you look at the resistance. I2 should be greater than I3 because R2 is smaller than R3. right? Okay, the larger the resistance, the less current. The smaller the resistance, the larger the current. There you go. That's a complex circuit.